Our third section for today's lecture is on solubility. In the previous section, we said that when you have an ionic compound, you dissolve it in water, it will dissolve completely, right? Well, actually, there is an actual limit to that amount of solute can dissolve in water. It's called its solubility. So, for example, in your everyday life example here, gout affects some men over the age of 40. And what is that? Is that when you have uric acid in your blood and it is in high concentration and it exceeds the amount that the blood, which is water, can handle. In this case, the limit of solubility for uric acid is for every 100 mils of blood, you can only dissolve 7 milligrams of uric acid at body temperature, which is 37 degrees Celsius. So then we'll take a look at other solubilities in detail now. So again, the solubility by definition is the maximum amount of solute that dissolves in a specific amount of solvent, and is something that is temperature sensitive. What do you think? If you have higher temperatures, how will it affect solubility? Right? When you try to dissolve something and it doesn't dissolve, what do you normally do? Maybe you might want to heat it up, the water, right? So the higher the temperature, the higher the solubility will be. It's often expressed in grams of the solute in 100 grams of the solvent. And usually the solvent is water. So there are different levels of saturations for a solution. When you are not fully saturated, it means that you did not reach the maximum amount of grams of solubility, you will call unsaturated. For example, if you were to dissolve salt into water, the solubility of salt is 36 grams per 100 grams of water. So let's say you have 100 grams of water and you dissolve 5 grams of salt in it. That solution will be called unsaturated, right? That means you haven't reached the maximum. That means that you can add more salt and it will still be dissolved. Let's say you have 35 grams now of sodium chloride in water. It will still be unsaturated because the limit is 36 grams. Now, however, if you add up to 36 grams of water, 36 grams of salt into that water, any more addition of salt will be undissolved. It has reached its limitation, so we call that a saturated solution. Right? So it contains the maximum amount of solute that can dissolve. If you add any more, you will see undissolved solute. So it will be probably floating or settling down at the bottom of that solution. Now, you may get something that's called a supersaturated solution. What that means is that if you heat up your sample really hot and you add, because when you have a hotter solution, more solute can dissolve, right? The solubility increases. So you add more, let's say for that salt NaCl, 36 was its limit. Let's say if you heat it up, you can add maybe to 40 to 50 grams of that 100 grams of water. And then you let it sit, let it cool down. Once it cools down, the solubility is still 36 grams at that moment, but still more is dissolved in it. And if more is dissolved in it than the maximum capacity, we call that a supersaturated solution. And over time, maybe some of the salt that was dissolved, that was exceeding 36 grams, will crash out eventually. And we call that recrystallization. Right here, recrystallization. Okay, so those are the three types of solutions: unsaturated, saturated, and supersaturated. Speaking about solubility, again, is that we already mentioned that it depends on the temperature. Most solids increases as temperature increases, whereas most gases will decrease as the temperature increases. So if you have like a soda can, if you increase the temperature, it will remove that gas from being dissolved in that liquid. So you have a flat soda can if it's hot. Right? Okay, and the checkpoint for this section. If the solubility of sodium nitrate is 114 grams per 100 grams of water at 50 degrees Celsius, how many grams of sodium nitrate will dissolve in 275 grams of water at 50 degrees Celsius? So at the same temperature, so that's good to know. Remember that we have a conversion factor in there, and we have our given Our given is 275 grams of water. What does our conversion factor say? Our conversion factor says that there is 114 grams of sodium nitrate that can dissolve in 100 grams of water. Notice then that those grams of water will cancel out. We multiply this, our answer becomes 314 grams because of 3 sig figs of sodium nitrate. So the answer there is C. In the previous section, we said that anytime you have an ionic compound you put in water, it will completely dissolve. Well, that is actually not completely true. So in this section, we will find out and we will apply when it is not true. So for example, I have 2 examples here. On the left-hand side is an example of a salt. It is a limestone, basically, so calcium carbonate, which is made up of calcium ion and carbonate ion. You think those are ionic compounds, so it will dissolve. But isn't this structure in the rain all the time? If this structure is in outside and when it rains, wouldn't water dissolve this? But water doesn't dissolve this, right? So that is an example of an ionic compound that is not it is not soluble in water. Whereas on the right-hand side here, salt, we know that salt is something that is soluble in water. So when can you tell something is soluble and when it is not soluble in water? This is a table that will help us do that. Okay, so here's how you read this table. Anytime that it has lithium, sodium, or potassium, basically the column number 1, it will be soluble in water, no matter what. It has no exceptions. Okay, these are exceptions. It has no exceptions. Same thing if you have ammonium ion as your cation, it will be soluble, no exceptions. On the flip hand side, what about anions? If you have nitrate or acetate as your anion, doesn't matter what you pair up with as your metal, as your cation, you will be soluble, right? So those 3 are pretty straightforward. They have no exceptions. Anytime it includes these ions in your ionic compound, it will be soluble in water. This next one, chlorine, bromine, and iodine, it will also be dissolved in water, but it has exceptions. If it is paired with silver, lead, or mercury, it will not be dissolved in water. It is not soluble in water. But if it's paired with anything else, any other metal, it will be soluble in water. Okay. And then if you are sulfate, this anion, you will be soluble in water, except when you pair it up with barium, lead, calcium, or strontium. These are the exceptions. Okay. And lastly, this last 2 rows right here is a little bit confusing, but it means that anytime you have carbonates, sulfides, phosphates, and hydroxides, you will be insoluble, except if those are paired up with these guys, right? Remember, these guys have no exception. So whatever rules is on top trumps rules that are on the bottom. So for example, if I had lithium carbonate, you will be soluble because lithium has no exceptions. Whereas when you have, let's say, calcium carbonate, that's going to be insoluble, right? Because calcium is not listed up here. But carbonate is listed down here as being insoluble all the time. So let's take a look at this. Using solubility rules, how can you explain these things crashing out? Right? Remember, if something is insoluble, it means it is not. It will be a solid in that liquid water. So, for example, cadmium and sulfur. Cadmium and sulfur. Sulfur, from the previous solubility table, we found out that sulfides are insoluble, except for sulfides are insoluble most of the times, right? So if it's paired with cadmium, it will be insoluble. It will crash out. Same thing, if sulfide is paired up with iron, it is not one of those exceptions on the top. It will crash out as this black solid. What about lead iodide? As you can see there, iodides are mostly soluble, but with three exceptions: silver, lead, and mercury. In this case, it is paired up with lead, which is the exception, so it will be insoluble. Next, we got hydroxides. Remember, we said hydroxides were insoluble for the most part, except for some. In this case, nickel is not part of that exception, so nickel hydroxide, or I should say nickel 2 hydroxide, will be insoluble. Questioning out is this solid species here. All right, so let's have a checkpoint. Which of the following solutes will not be soluble in cold water? So let's go through this list. Lithium hydroxide. Lithium is always going to be soluble from the rule, so not the answer. Sodium chloride. Sodium and chloride will be always soluble, so not an answer. KBr, potassium, is always going to be soluble, so not an answer. Calcium phosphate. Phosphate will be always insoluble except with lithium, sodium, or potassium, right? So calcium is not part of the exception, so this will be your answer D. It will be insoluble in water.